All right. Well, some of you watch people play video games on YouTube. I guess now you get to watch your math teacher do proofs. Uh, don't know if it's quite as exciting, but I'll try my best. I'll try my best here. Want to go over a few of these questions, especially for the folks that maybe haven't been in class. So here we go. I'm going to go over like 3 questions. So number 1 was a tricky one. We went over that one in class. There's some key definitions that you want to be aware of here. I'm just going to go through and talk through it here. For me, my letter A, Josh is trying to prove a statement about all prime numbers that he believes is true. No proof of the statement exists. That's the key part right there. No proof exists. That's what makes it a conjecture rather than a theorem. If it's been proven, if you can prove it, then it's a theorem. B says Lucy proved a certain statement about polynomial functions. If she proved it, it's a theorem. Letter C, DeAndre wrote a proof that included the following statement: a right triangle is a triangle with one right angle. That would be considered a definition, something you would see in a textbook, for example. Letter D, Michael wrote a proof that included a certain statement. The statement is not a definition, but is accepted as true. Okay, so it's an accepted truth without proof. That is the definition of a postulate. And lastly, in her textbook, Martina found a proof of a certain statement about right triangles. That would be a theorem. If there's a proof, that would be considered a theorem. Okay. The only one that we didn't use there was undefined term. Undefined term would be like a point, plane, or a line, because they are not a defined position or place. They go on infinitely, so those would be considered undefined. Okay. All right, let's go over to number 3. All right, so here's the proof setup here. ALEKS makes it kind of nice. You can send the first given to the proof just by clicking send to proof, and it sends it right there. Okay, so I'm trying to prove A is parallel to B. I have 8 and 4 as congruent already. So to me, it makes sense that I'd want to show perhaps that 8 and 6 are congruent, and if I can show that, then I could use converse of the corresponding angles theorem. I could use converse of the corresponding angles theorem to show that the lines are parallel here. Okay, so let's see what I can do here. All right, so first I have angle 4 is congruent to angle 6, and the reason for that would be their vertical angles. Okay, validate. All right, now let's use the transitive property to show 8 and 6 are congruent. So angle 8 is congruent to angle 6. Reason would be transitive property. Using statements 1 and 2, see how 4 is congruent to 8 and 6, so that means 8 and 6 are congruent. Validate. All right, now I can say the final statement, I can send it to proof, and the reason is 8 and 6 are corresponding angles, so it would be converse of the corresponding angles theorem. So converse, yeah, this one right here. Validate, proof is complete. So there we go. All right, let's try another one. Let's do this one where we're trying to prove angles. So we're given parallel lines and we're trying to show angles in this case. So let's send the given to the proof. R is parallel to S. And we're trying to show that 3 and 6 are congruent. Okay. So if R is parallel to S, I can't use alternate interior angles theorem because that's what 3 and 6 are. But let's say I could do 2 and 3 are vertical, and then I could say 2 and 6 are corresponding. I could do that and then use transitive property after it. So let's try that. So I could say angle 3 congruent to angle 2. Reason, vertical angles, property, validate. And then I could say angle 2 is it congruent to angle 6. Okay. So I'm ultimately trying to relate angle 2 to angles 3 and 6 because I know that's what I'm trying to show. I'm trying to show that those 2 angles are congruent. So I'm choosing angle 2 because I know 2 relates to both of those angles. So it's a key angle in my proof. So I'm going to go angle 2 congruent to angle 6. Reason is they are corresponding angles. So I'll scroll down. If lines are parallel, then corresponding angles are congruent. Validate. Now I can use transitive property to say angle 3 is congruent to angle 6, and the reason would be transitive property. Validate, and I'm done. Okay. see if there's any more to do here. Let's do the segment proof. PR equals ST. Okay, PR equals ST. So there we go. And I also know PQ equals QT. Okay, let's go ahead and define ST and PR because I know those are equal segments. So let's go ahead and use segment addition to define PR and ST. So PR equals the two little segments, PQ plus QR. And the reason is segment addition. Segment addition property, validate. Let's now do ST. ST equals, let's see, SQ plus QT, right? SQ plus QT. Reason is segment addition, validate. All right. So now we have some givens here that we can use here. Well, we know PR and ST are equal, so that means that I can set PR and ST equal to each other. So I could say PQ plus QR equals SQ plus QT. So I just took statements 3 and 4 there, and I looked at what PR equaled, and I looked at what ST equaled, and I realized, well, if those have to equal each other, then PQ plus QR has to equal SQ plus QT, and that would be substitution, because I have equality here, so I'm using substitution. All right, I'm trying to show QR and SQ, but I also know PQ and QT are equal from step 2. So I'm going to replace PQ with QT through substitution, and I'm going to rewrite the rest of it. And the reason I'm going to do that, so it's substitution. The reason I'm going to do that is then, look at, if I subtract QT from both sides, they will cancel now, and I'm going to get what I want, which is QR equals SQ. QR equals SQ. The reason would be subtraction, because I subtracted QT from both sides. Addition and subtraction, validate, and there we go. All right, people. What do we think? Hopefully that helps a little bit. If you need anything, don't hesitate to reach out. I'm always here. Okay? Thanks for watching, and I'll see you next time.